Right, I want us to look at a general solution. Once we talk about a general solution, it simply means there's a specific solution. For example, if sine angle, I think we've just done this before while we were doing reduction formulae. Suppose we've got an angle here which is 30 degrees. Remember, when you do the section, you do it in connection with our trigonometric graphs. Remember our graphs, our three. For example, if we look at y is equal to sine theta, where theta is between 0 and 360. Let me just make an example of this graph. If I'm sketching this graph, remember this is what I will do. What is generally the period of sine graph? It is 360. This is 180. This is 90. This is 270, your quadrants. When I was sketching the sine graph, it is between -1 and 1. This is -1 and 1. Generally, the sine graph is between those two. A graph is y. So y of this graph will be between these two because the amplitude here is 1. So all that I need to do is to take the period to divide by 4 to get these intervals. Now, remember the sine graph will start from here. You must have an idea of it. It will turn there. It will come back to cut here. It will come back to 10 at -270 and -1 and back to 360. This is what typically a sine graph will look like. Make sure that it has got smooth curves. Number 2, when you talk of a cosine graph will start on top there, come down, turn, and go back there. Number 3, this is number 1. This is number 2. Number 3, tan graph becomes important here as well. Remember your tan graph, what is the period? The period of these two graphs is 360 degrees. The period of sine graph and a cosine graph, both of them are 360 degrees. What is the period? In terms of graph, a period is when you can sketch a full graph. The full graph is 0, 360. So this is the period. This is the period of graph here. Look, from 0 to 360. That's why I'm showing it from 0 to 360. So this is also telling me something. So we're starting from here to here. So the period of this graph is 360 generally. These are other graphs. When you talk of the tan graph, the tangent graph, if this is 360, if this is 180, so this will be 90, this will be 270. Remember, a tan graph has got what we call asymptotes. Lapho ungakwazi ukuthola khona ivalue ka-tan graph. In other words, there are asymptotes at 90 degrees. There are also asymptotes at 270 degrees. If you check in your calculators and you look for tan 90, it will be undefined. So the graph is not going to touch 90 degrees. The same thing with 270. We can sketch a full tan graph between 90 and 270. We can sketch a full tan graph here. From between here and 0, we can sketch a halfway graph. So it's not to be halfway graph. So the period where we can sketch a full graph is from 90 to 270. What period is that? It's 180. So the period of a tan graph is not 360 but 180. So I can sketch a full tan graph between 90 and 270. It calls for the period to be 270. So here I will show only the half of it. I will not see this part negative. And this side I will show half of it. So the full graph the full period of this graph is 180 degrees. The full period of this one, this will be 0, that will be 360. So I can sketch the full graph between 0 and 360. Hence the period of this graph, we say it is 360. And the period of the sine graph is 360. But this graph is continuing. It can continue and continue and continue up to infinity. So a general solution is just looking for that continuation, for that continuation. We know that a sine graph period of 360, a cosine graph period of 360, whereas a tan graph period of is 180. So this becomes important when we're dealing with the general solution. Specifically, the solution of this angle is 30 degrees. That's a specific solution. Suppose we're dealing with sine, and we know that a sine graph period of 360. But I've got only 30 degrees. But if I go, the solution to this graph, the solution is equals to 30 degrees. But this is not the only angle. Specifically, it is 30 degrees. But this is not the only angle that is equals to, that falls in this arm. Remember, from this angle, if I can add 360 from this angle, I will go back to the same position. So there are so many other angles that falls within this position. Hence, we say general solution, not a specific solution. It's not only 30 degrees, but there are so many other angles. It depends how many times do I rotate. So 30 degrees is the solution plus 360. If I add 360 on this angle, I will also be in the same position. So if I add 360, why 360? The period of a sine graph. I'm dealing with sine and cos. Sine and cos, they do the same thing. So I will add 360 of the period of that graph, depending times k, where k is an element of z. You can use n if you like. Other books use n, others use k. What is this k? This k stands for the number of times I've rotated around that, the number of 360 I've added. If I did not add 360 in this angle, the answer would be 30. If I did not add 360, so in other words, I did not rotate. So the answer, the k here will be 0. So I did not rotate. 360 times 0 will be 0. This will only be the solution. But if I've made a rotation, one rotation, the answer will be 390, and so on and so forth. So k is an element of integers, or 1, 2, 3, or minus 1, minus 2, minus 3. So that's what we mean by a general solution. When we are dealing with what? When we are dealing with sine graph and cosine graph. But when we are dealing with tan, instead of 360, what do we put here? We put its period, which is 180. That's the difference between the two. So when we talk of a general solution, we are not looking at a specific solution. We also check the period of that graph, the rotations. This stands for the number of rotations that I do in that particular graph to give me a general solution. A specific solution, it will be 30 degrees, but a general solution, there are so many other angles that belongs to this arm. Right. Let's look at how this is such. Another important factor in this one. Remember when you're dealing with sine and cos, this is very important. When you deal with sine and cos, this graph is sketched between -1 and 1. Now, what happens when I have maybe sine theta is equal to 5? You are not going to accept this. Why don't you accept this? Because this is a graph, so it is 5. This graph, you will never find it at 5 because it is between -1 and 1. So whenever you have a situation like this, this is not applicable. You just say, you cannot find this because sine graph is between 1 and -1. When it's the same thing with cosine graph. When you find something that is above, that is beyond -1 and 1, we are not going to move on with that because we are not going to find the solution. However, when we deal with tan, tan is continuous up and continuous down. It can be any value. Tan theta can be 7 because of tan graph you can find 7. Oh, why is 7? It can be 20, it can be 35, it can be anything. But when you are dealing with sine, cos, you always confine it between -1 and 1. So the only values that you can accept here are any values that are between 1 and -1. When you find something above 1 or something below -1, you leave it there. You're not going to find the solution because a sine graph is sketched between 1 and -1. It's mother graph, of course. Now, I want us to, with this in mind, to go and do a few problems. We'll just do 2 to illustrate this. Now, this angle that I had there, which was 30 degrees, becomes important when we do the general solution. Remember, if I had this angle as 30 degrees, it is the angle that I will be adding on it. So it becomes important. It becomes what we call a reference angle. And the Cartesian plane is important. Remember, how do you call the first quadrant? It is theta, or 90 minus. How do you call the second quadrant? It is 180 minus theta. The third quadrant, it's 180 plus theta. The fourth quadrant is 360 minus theta. Take note. When we deal with the general solution, we don't use 90 and 270. You only use 360 and 180, as I've indicated here. In the general solution, avoid using 90 and 270. Only use 180 and 360. Right. The idea behind the general solution is to isolate whether it's sine of that angle, tan of that angle, or cos of that angle. Whatever we give you, we want you to present this in the form of sine is equal to something, or cos is equal to something, or tan x is equal to something. That's what we want to get, so that we can find our reference angle. It can come in any form, but we know what we want. We want to have, at the end, we want to have sine x is equal to something. In this particular case, we will want to have tan x is equal to something. Let's do this thing. Now, how do I isolate this tan x? This 2, I've got to take it that side. What will I have? I will have tan x minus 1 as the same as what? This times that, it is minus 6. Let's make tan x the subject. Then tan x is equals to what? You take this minus 1 that side, it will be positive, so this will be minus 5. Right, this is what we have. That is the starting point. It is important that whatever method of general solution we want, this is the part that we want. Once we have this part, then we can be able to move on. Now we've got tan x as equals to something. Take note, your eyes becomes important in this particular case. Tan x, how is it? Is it positive or negative? Tan x, how is it? Is it positive or negative? That becomes important because we know all students take Coke. Now, when we say tan x is negative, which quadrant is that? Where is tan negative? Where is tan negative? Tan is negative in 2 quadrants. So we're going to have it in 2 solutions. Tan is positive there, tan is positive there. So it is negative in this quadrant and also negative in that quadrant. 2 quadrants. The second as well as the 4th quadrant. So that's where I will find my solution. My solution will be in the 2nd quadrant where tan is negative, 2nd quadrant, or just quadrant 2. As well as the other solution will be in the 4th quadrant. 4th quadrant. That's where I will be finding my solution. Asikhumbuleni ukuthi sibiza ngobani i-2nd quadrant. Go 180 minus, sibiza ngobani 4th quadrant with 360 minus. So that's how we refer to the 2nd quadrant and the 4th quadrant. Okay, singakhohlwa futhi sikhuluma ngobani ngo-tan. Ithini period ka-tan graph? You-180 degrees. Now, let's move on. This is tan is equal to minus x. Remember in one thing only. Tan akanayo limit. It can go up to the positive infinity and it can come down into the negative infinity. What if here we had sine x equals to minus 5? No solution. Because tan is between minus 1 and 1. It's between 1 and minus 1. Once we have minus 5, we're not going to find a solution. Right. But in this case, because dealing with tan, it can be any value, any positive and any negative value, because tan goes to the positive infinity as well as down to the negative infinity. Now, sibiza kanjani is 2nd quadrant. So I see our solution, in this case, our x that we're looking for will be equals to, because it is in the 2nd quadrant. Sibiza in the 2nd quadrant, sibiza 180 minus. It's going to be 180 degrees minus theta plus the period yakhona, which is 180 k, where k is an element of integers. K made 1, 2, 3. So it depends on the number of rotation. Period. Now the challenge then becomes this theta. What is this theta? We call it a reference angle. A reference angle. This becomes your reference angle, your reference angle, your reference angle, your reference. To find the solution that you've got to find the reference angle first. 360 minus yon. It is usually an acute angle. Let's move in. Now, how do you find this reference angle? From this position, that is how am I going to find my reference angle? How do I find it? I solve for x here. How am I going to do that? I'm going to say x is equals to arctan of 5. I no longer write the negative. Ngoba negative ubungisiza ukuthi ngithola ama quadrant. Lawo senginawo mabili where tan is negative. But mase ngifuna a reference angle, I don't use this negative because I've already used it to determine the quadrants where I'll be finding my solution. Now, I go to my calculator and find this reference angle. I go to my calculator and check what is arctan of 5. In your calculator, you press shift tan, which will give you the arctan of 5. What is the answer? The answer we get is 78.69. Remember, a question, if it is correct to 1 decimal, I don't lose sight of that. So it's 78.69, which will give me 78.7 degrees. This is the value of x. What is this x? This x is the reference angle. These are the angles, depending which quadrant it is. So this 78.7, we refer to it as the reference angle, the one that we use here. So the actual solution in this case will be x is equals to 180 degrees minus the reference angle, which is 78.7 plus 180k. I don't have to repeat that again. Then the x will be equals to, quickly check this in our calculator, it's 180 minus 78.7. It should be 101. What is it that I get here? It's 101.2. Yes, it is 101.2 plus 180k. This is the machine. Generally, this is how I will write the general solution. It can cater everything because of this machine, depending on the number of rotations. Okay, in the fourth quadrant, sibiza kanjani fourth quadrant? This is the fourth quadrant. Yona sibiza with 360 minus. Remember, the angle that we subtract is still the same thing, the reference angle. So in that case, we would have our solution as equals to, because we're dealing with the fourth quadrant, it will be 360 degrees minus the reference angle. 360 minus 78.7, 78.7 plus 180k, where k is an element of z. You work that one out, it will be 360 minus 78.7. What is it that I get? I am getting 281.3. This then is equals to 281.3 plus 180k, because the period of this one is 180 degrees. This is how we do the general solution. However, this will only stand as the solution, not that one, because we're saying period katan is between 0 and 180 degrees. So that's how we do the general solution. But this is not the only type of general solution that I want us to look at. At times, there will be a general solution where it will want us to factorize. I want us to look at that particular type. How do we deal with that part of general solution? Thank you.